We study X13NQ. From today on, I have included the N. That is for the students who are not familiar with concepts given in corresponding Q. So, if you do not have any difficulty to solve problems in X and Q, you doesn't have to look at X13 and Q. But if you have some difficulty to study 13Q, then you are advised to review NQ first and then try Q. So let me briefly finish that part and Q. The trajectory of a particle of mass m is this. It is a circular motion, and we have a unit radial vector, center, the radius, where r, radius r, and angular frequency omega are constants. So the system is making a uniform circular motion, which is different from the others. First, mass, length squared divided by time. Mass, length squared, mr squared, and time. You remember omega is angle divided by time, and this one is dimensionless, and this is time. Mr squared omega seems to be the one corresponding having the same quantity, the same dimension. Dimensions of mass, velocity, mass velocity, linear momentum, and x. This problem, x is RER, and momentum is mass times velocity, and because x is RER, x dot equals r dot ER plus RER dot, Leibniz rule. Because r is a constant, r dot equals 0. And ER dot, that is, by making use of chain rule, and what is this? Time the angle derivative of ER is minus E1 sine theta plus E2 cosine theta. This is E theta hat, that is perpendicular to ER hat, and E theta hat perpendicular to the radius. So this one is E theta, and this one is a theta dot, that is omega. So R theta dot E theta. So if I substitute m r theta dot E theta, x cross p, this is m r theta dot E theta. So if I combine everything, mr squared theta dot ER times E theta. It is something like E1 cross E2. they are perpendicular to each other on the plane. So this is a E3 hat. If you're not familiar with this, you can just multiply. Okay, 1, 1 vanishes, 1, 2. Cosine square. 2, 1 vanishes, 2, 2. Oh, no, 2, 1 survives. Sine square theta. And 2, 2 vanishes. This is the E3 hat, cosine square. And this is 2, 1 minus E3. So minus minus plus E3. So E3 cosine square sine square E3 hat. Okay, E3 hat. MR theta dot equals omega. Aha! They are, I think they are the same. T times the dimensions of energy. Energy. For example, 1/2 mv squared. Kinetic energy. Oh, forget about this when we consider dimensions. Velocity, length divided by time squared multiplied by time. So m L squared and t minus 1. Okay, the answer should be D. Dimensions of linear momentum divided by the dimension of linear momentum times the dimension of length. Linear momentum, length. Okay. Trajectory of a particle of mass m is the same problem. Which one is not invariant? Angular momentum, x plus t. It was mr squared theta dot E3 hat. Radius omega, theta dot is omega, constant, so it's a constant. Kinetic energy, 1/2 mv squared, but that is 1/2 m r theta dot E theta squared, 1/2 m r squared theta dot squared. By the way, r theta dot constant, so it is also constant. Net force, it is making a uniform circular motion. Anything making a uniform circular motion accepts the net force toward the center is minus mr theta dot squared er hat, and er hat is omega t, so it magnitude of the force is the same, that is independent of time. However, direction of the force keeps changing, so it is not correct. The total mechanical energy, because the total kinetic energy is invariant, the potential energy must be the same, constant. And the normal force, the net force is the constraint force to make this particle restricted on a circular path with a constant uniform speed. So there is no potential energy at all. Again, the same problem. Which one does not vary periodically? Net force and centripetal force, in this case, they are the same. It changes and returns to the same point, and with the angular frequency, the period is 2 pi over omega. Okay, they are periodic. Linear momentum. Omega t, so it keeps changing, but its period is identical. Velocity. Because I can divide this one by mass to obtain the velocity, it is also periodic. Theta dot E3, theta dot is constant. E3 constant vector. It's not the answer, it is the answer. Trajectory of a particle of mass m is, again, the same problem. Okay, find the set which is not on a single plane. X is on the xy plane. X is parallel to, proportional to ER. X dot proportional to E theta. And X cross V. X cross velocity. This is proportional to R theta. We know that this is E3 hat. So ER, just like E1, E2, and E3, ER, E theta, and E3, they are orthogonal to one another. Okay, not a single plane. So this one is not a single plane. X dot, that's fine. But X cross X, this is zero vector. This is a zero vector. So they are on a single plane. X dot, that's fine. And then, okay, again, X dot cross X dot, parallel vector cross product equals 0. Again, it's a 0. It's a 0, 0, single unit vector. But anyway, they are all on a plane. And actually, this is on a straight line. 5. The trajectory of particle mass m is like that. Which one is different from the other? The velocity of the... Okay, let's compute the velocity of particle. And actually, we have already computed this r theta dot E theta hat. Okay, to compute this, this is r times ER hat. We take the derivative. Because r dot equals 0, it is factored out. And then when I compute the time derivative of cosine, I made use of chain rule. Sine, chain rule, and then multiply time derivative of angle. Okay? So this one is a minus sine, and this one is a cosine. And I have factored this theta dot out. Okay, the B is the same as a velocity. What's that? C. Everything is the same, except that we missed theta dot. Is missing, so this is the answer. What about this? E3 cross E1, 3, 1, 2. So equals r theta dot E2 hat cosine. E3 cross E2. That is a minus E2 cross E3. And this is E1 minus E1 hat. therefore minus E1 hat sine theta. Okay, that is identical to the E theta hat. So this is C is the answer. Trajectory, again the same problem. Which one is different from the others? Angular momentum of the particle x cross p, and that is mass times velocity. They are identical. And what's that? mr theta dot e theta hat r e r hat cross equals m r squared theta dot e3 hat. Okay, these are single power is missing. This is wrong. This is right. Trajectory of a particle, again the same problem. Compute the acceleration, angular momentum, and the kinetic energy of the particle. Acceleration, taking the time derivative on a particle that is making a uniform circular motion, can always be computed equivalently by multiplying omega cross. So if I have a double time derivative, I have omega cross to the position vector. And we can apply back-up rule. A cross B cross C back cap and A B C omega x omega x omega x. So the answer is omega dot x minus x omega squared. Okay. By the way, this is making a uniform circular motion. Position vector is perpendicular to the axis of rotation. So E3 omega, they are parallel. Omega and x are perpendicular to each other. This one vanishes. Only r omega squared survives. Angular momentum x cross p. That is x times this, and the time derivative is omega cross x. Again, we make use of the chain of the back-up rule, but back-up rule with x omega x, ABC x omega x, a omega x, a omega x. So the answer should be omega x squared. We have a mass m here, and then x dot omega, x dot omega. Again, we have omega perpendicular to the plane, circular plane, and x is perpendicular to omega. This one disappears. We have m x squared. This x is just a nothing but the perpendicular lever arm vector relative to the axis of rotation. So mass times lever arm squared, that is called moment of inertia or rotational inertia. Third, kinetic energy of the particle. Kinetic energy, that is omega cross x squared. Velocity is omega cross x. So if I make a square, this is a cross product. It is proportional to sine squared theta. Therefore, it is 1 minus cosine squared theta. That is, if I factor this omega squared x squared out, it is nothing but 1/2 I omega squared. The reason is that, again, omega and x are perpendicular to each other. This one vanishes. 1/2 omega squared, labor arm squared. I is mass times labor arm squared. Okay, that's it. If you completely understand this part, you can begin with X13Q.